Motion tracking is a large subject, so in these movies we're only going to be able to hit the highlights. You'll want to definitely read the Shake manual and try the Shake tutorials to learn more. But to see how the tracker node works, let's load some footage. We'll come to the Image tab, click on File In, click on the pop-up menu, exercise File Assets, select the Footage folder, come down to Match Move, and select all the Match Move sequence frames. All right. Okay. Next, we'll add the tracker node. Click on the Transform tab. Click on Tracker. And to see what we're doing, we need to adjust our windows. So I'm going to move this over here and move that window up there so we can see all the tracker parameters. And the next thing we'll want to do is to set the time range. So we'll go to the Globals tab, click on Auto, set it for 48 frames, which is the length of our input node. Come down to the timeline and click on that to set it to 48 also. Back to the Parameters tab so we can work on our tracker node. Again, the tracker node only creates tracking data. It does not actually apply it to anything. You have to then link this tracking data to other nodes to do the transformations. We'll have a separate movie on how to link parameters. You'll see how to do that later. But the motion tracking that we're going to see here is common to all the motion tracking nodes. So let's start by seeing how we set up a tracking point. We come down to the viewer shelf and turn on the on-screen controls. And our first tracking point appears on the screen. Unfortunately, it's very similar to the color of our car, which is why Shake thoughtfully offers you this color chip. Click on the color chip. We'll come up here to our colors and we'll click blue. I've now changed the color to something I can see better. Let's zoom in and take a close look at this track point. There's this outer ring and an inner ring. The inner ring is what Shake calls the reference pattern, or what I call the match area. It's this area when we place it over a target, like this lamp here. This is the rectangle that will be copied and used as a reference for all subsequent frames. All the following frames are going to correlate to this point to find the match. If I step forward to frame 2, now the search box becomes important. What Shake will do on frame 2 is it will search inside this outer box looking for the best match of what it captured from the start frame in the reference. When it finds the best match, it'll move everything over to it and call that the track for frame 2. This process is then repeated for the entire length of the shot. You have the ability to adjust the size and even the shape of both of these boxes, which can be a very handy feature. There is also on-screen information here. This first field here, let me move that so you can see it better, gives you the name of this track. The default name is track 1. This is the X position on the screen, the Y position. This C is the correlation number. How well this frame correlates with the reference frame at the beginning of the track. We'll see more about the correlation number in a minute. And time is, of course, the current frame that you're on. One important thing you want to do in your motion tracking is to name each of your trackers, to give it a logical name so that you don't get confused over which track you're talking to. So we'll come down to our parameters. We'll click on this name here, and we'll call it Lamp. Our tracker is now named Lamp. I'll reposition him on frame 1. We'll home this, go back to frame 1. Here we are. Okay, the next thing to know about is the track range. The default is it'll track the full length of the shot. If you only wanted to track a short range, like frame 10 to 30, you would enter that here. Next, I'm going to turn off the limit processing, which simply controls the view of the shot. We'll see more about that in a minute. And now we're ready to track our first tracking point. We have to make sure we're on frame 1, so always make sure you're on frame 1, and also make certain that you have the tracking node in the viewer. If you have the source image in the viewer, the tracker won't track. So you've got to double click and make sure the tracking node is what's in the viewer in order to enable the track forward or the track backward buttons. So let's track forward. Zoom. Done. Okay, so we now have tracking data for the 48 frames on that one lamp. Let's take a look at the tracking data that we got. I'll come up here and lower this window so that we can see the curve editor. Scroll down here and we'll unfold our track 1, which is the lamp. And here's the X and Y and correlation data for this frame for that track. Let's turn on the X and the Y. So this is the actual data collected by the tracking point. This is where it located each point frame by frame. Notice the lamp correlation number here. This changes from frame to frame, and you will recall that that number quantifies how well each frame correlates to the beginning reference frame. You can see the correlation is getting worse and worse over the length of the shot. This is normal. And this correlation number is extremely important to your well-being in motion tracking. We'll fold this up, go back to our node view, set our windows up here, and take a look at how that correlation number affects our motion tracking. This is the threshold for the correlation number. If the correlation drops below this failure tolerance threshold, it kicks in the failure behavior, which in this case is stop. As you can see, there are several potential behaviors. Normally, stop is what you'll want to use. This means if the correlation number falls below the failure tolerance, then it trips the failure behavior. Similarly, there's a reference tolerance. Again, the number in this window is the threshold for the correlation. If the correlation value crosses this threshold in the reference tolerance, it kicks in the reference behavior. And again, you have choices of different reference behavior, and the default is to use the start frame. Just to show you how this works, I'm going to set the failure tolerance to 0.9. So if my correlation drops below 0.9, the failure behavior is stop. So let's roll back to frame 1 and tell it to track. Bang! It stopped on frame 29 because my correlation dropped below 0.9. See how that works? We'll set the failure behavior back to the default at 0.5. Return to frame 1. Now let's talk about how we add more tracking points to our shot. Come down to the bottom here and click on the Add button. You see it's added another tracker here. So we'll grab this guy and move him over here to another point we want to track, like say this window. We'll scroll down and we want to add another point. It appears in the list. It pops up on the screen. We'll move that where we want it. Scroll down. Click on Add again. We have a fourth point. We'll select those and move him where we want. We now have 4 points on the screen. We can now do the track forward. A minute ago we talked about limit processing. Here's this guy here. If you turn limit processing on, Shake is going to automatically crop the viewer to just those pixels that are important in the motion tracking, and it'll look like this. Track. There you go. So the purpose of this is to save the processing time of loading parts of the frame that you don't need. Personally, I like to see what I'm doing, so I turn limit processing off. We now have collected the data on 4 different tracking points. We can now feed this data to any other node we want to apply it to a transformation. And we do that by linking it to the nodes, which again, we'll see in another movie. In this movie, we saw how the tracker node collects tracking data for any number of tracking points. But this data then will have to be linked to other nodes to actually do the transformations. The tracking information we saw in this movie is applicable to all the following movies, starting with the Stabilize movie, which is next.